So to select the correct volume type for your workload, there are a few things you need to be aware of and understand. So these are the factors that will impact the performance of your volume, the optimization strategies, the different volume types and their characteristics. And once you understand these, you can then select the correct volume type for your workload. And we're going to look at each of these now. The performance of your volume is going to be shaped by a variety of factors, and common factors impacting your volume's performance will include a lack of free storage space, the volume type and its characteristics, and the limits of those volumes, and the latency. So the first thing to be aware of is the key performance metrics. So as a rule of thumb, the performance of any storage system is going to be impacted by its IOPS, its throughput, and latency. Now latency, this is the time taken to complete an I/O operation, and you measure latency in milliseconds. So the lower the latency that you have, this is going to be essential for applications that require quick data access. So factors that would affect latency would be your network bandwidth, your I/O size, and your queue length, and these can all impact latency. So next we have IOPS, and this stands for input output per second, and this measures the number of I/O operations that your volume can handle per second. Your third key performance metric is your throughput, and this is the amount of data transferred to and from your volume per second, and throughput is typically measured in megabytes per second. So another factor that's going to impact the performance of your EBS volumes is the different I/O characteristics. Now with EBS we have two different categories of volumes. We have our SSD-backed volumes and our HDD-backed volumes. So with SSD volumes, these are designed to work best with small I/O operations, whereas your HDD volumes, these are designed to work best with large I/O operations that are sequential in nature. So in order to understand how your SSD and HDD volumes will perform in your application, you need to be aware of the different I/O characteristics that can affect your chosen volume's performance. So for I/O characteristics, we have I/O size, IOPS, and throughputs, and these are all interconnected, and they can influence the performance of your EBS volume. So your I/O size, this refers to the size of data chunks that are read from or written to your EBS volume. So with IOPS, this is input-output operations per second, and it's the number of your read and write operations that occur in a second. With throughput, this is the amount of data that's transferred to and from your EBS volume, and throughput is calculated by multiplying the number of IOPS by the I/O size. Now throughput, this has a direct relationship with the I/O size, so as your I/O size increases, the throughput will also increase. Conversely, your IOPS has an inverse relationship to the I/O size. If your I/O size decreases, your IOPS can potentially increase because they're the opposite. So if your I/O size is quite large, you'll actually get less IOPS than what you expected or provisioned for your EBS volume. So as your I/O size is directly linked to the throughput, if you have a larger I/O size, you're going to actually reach the volume's throughput limit before you hit the IOPS limit. So by understanding the relationship between these three factors, you're going to be able to identify the elements that may be affecting the performance of your volume, and this is going to help you optimize your workload as necessary. Another I/O characteristic that's going to influence the performance of your EBS volume is what's known as I/O merging. So on the application and operating system, here you can define the size of your I/O operation. But on the EBS side, the underlying technology will actually determine the maximum amount of data that a volume counts as a single I/O operation. When I/Os are moved from EC2 over to EBS, and they're going to be counted up, EBS is going to determine how much of those operations is actually counted as one IOP over on the EBS side. So for your SSD volumes, the maximum I/O size is 256 kilobytes. For your HDD volumes, the maximum I/O size is 1024 kilobytes or 1 megabyte. So when you've got small I/O operations that are physically sequential in nature, so they're one after the other, EBS will merge them into a single I/O operation up to the maximum size for its volume type. Likewise, EBS will actually split I/O operations that are larger than the maximum size into the smaller I/O operations. So when the I/O size is smaller than 32 kilobytes, or if the workload is random, EBS won't merge the I/O. They're all counted as individual operations over on the EBS side. So to explain this in more detail, let's have a look at a few examples that I've put together. So in the first example, here we have our EC2 instance, and attached to it is one of the SSD EBS volumes. So here we can see that we've got 4 I/O operations that are being sent from the application on EC2 over to EBS. And these operations are all random in nature. So when they arrive at EBS, they're not going to be merged. So EBS is actually going to count them as 4 individual operations. And if we look at our second example, here again, we've got our EC2 instance, and it's also got the same SSD volume attached. And this time we've actually got 4 operations, which are sequential in nature. So they're one after the other, and they're each 64 kilobytes in size. So when these 4 individual operations land over on EBS, EBS is actually going to see that they're sequential in nature and they're smaller than the maximum size of 256 kilobytes. So EBS will go ahead and merge these 4 IOs, and it's going to count them as one IO operation. And here's an example of how the IO merging happens on our HDD volumes. So again, we've got our EC2 instance and we've got our HDD volume over here on the right. So these 2 IO operations that are being sent over from the application on EC2, they're both 512 kilobytes. They're physically sequential. So when they arrive over on the EBS side, EBS is actually going to count them as just one IO operation. So the merging of IO operations by EBS, this provides you with a couple of key benefits. First of all, you've got improved performance. So by combining small sequential IO operations into larger ones, EBS can actually reduce the overall number of IO requests, and this leads to better throughput and lower latency. The IO merging makes efficient use of your IOPS, so merging helps maximize the use of your available IOPS, and this is good for SSD-backed volumes where the IO size is capped at 256 kilobytes. So this allows applications to effectively achieve a higher IOPS rates than if they weren't being merged. So another factor to consider that'll impact the performance of your volume is actually the IOPS and throughput limits of both your EC2 instances and your EBS volumes. So both the EBS volume and your EC2 instance have their own IOPS and throughput limits. So EBS limits, these are based on the volume type and size, and we're going to cover this later in another slide. So while your EC2 limits, these are going to actually depend on the instance type and size. So it's important to be aware of these limits, as your volumes could actually be limited by the EC2 instance that it's attached to. So if we have a look at the AWS docs to see this as an example. So if we had an M5.4x large instance, this actually has a maximum throughput of 593.75. So if we were to attach a GP3 volume that was provisioned with 800 megabytes of throughput, the volume would actually never reach that full 800 megabytes, as it's actually going to be limited by the 593 megabytes that the instance can achieve. Also, the throughput and IOPS of your EC2 instance is going to be shared amongst the EBS volumes that are attached to it. So you really need to consider the instance type and its performance when you're attaching multiple EBS volumes to the EC2 instance, as the volumes are actually going to be sharing the available bandwidth and IOPS of the EC2 instance. So that's an important factor to be aware of, that your EBS volume can actually be limited by the instance it's attached to. Another factor to consider is EBS optimized instances. An EBS optimized instance, it's a type of EC2 instance that provides dedicated network capacity for EBS I/O. So this ensures optimal performance as it minimizes contention with other traffic from the instance. Previous generation instances, some of them are not EBS optimized, so they're going to share network bandwidth between EBS and other tasks, and this can lead to performance issues if the network is being heavily used. So EBS optimized instances, these have dedicated bandwidth for EBS traffic, and this is separate from the instance network bandwidth. So EBS optimized instances, they offer consistent and high performance by separating EBS traffic from other network activities. So for example, if you're running a database on your EC2 instance, and this database is constantly reading from and writing to the EBS volume, what you'd want to do is you want to ensure that the network path between your instance and volume is not congested by other network traffic, like data being sent to and from your application over the internet. So by using EBS optimized instances, you can significantly enhance the performance and reliability of your EBS volumes. So another factor that'll impact your volumes performance is the EBS burst model, and this is specific to your GP2 and HDD volumes. So the general purpose GP2 volume is designed to meet a range of workload requirements. So GP2's baseline performance is determined by its size. So for each gigabyte, you get 3 IOPS. and this comes with a minimum of 100 IOPS. So for example, if you're running a 100 gigabyte GP2 volume, it's going to have a baseline of 300 IOPS. As you have 100 gigabytes, and that's going to be multiplied by 3 IOPS, so that's 300 IOPS. So GP2 volumes smaller than 1000 gigabytes or 1 terabyte, they can burst up to 3000 IOPS for extended periods. So this bursting ability is controlled by IO credits. Now each GP2 volume smaller than 1 terabyte will start off with 5.4 million IO credits, and this allows the volume to burst to the maximum of 3000 IOPS for 30 minutes. So when the IO demand is greater than the baseline performance, the volume will begin to spend those IO credits in order to burst to meet the required performance. And again, it's only going to be able to burst up to 3000 IOPS. So when all of the IO credits are used, the volume will perform at its baseline level. So when the IO demand drops to baseline performance or lower, the volume then starts to earn the IO credits back. And that's going to earn it back at a rate of 3 IO credits per gigabyte of the volume size per second. So the more IO credits a volume has accrued, the longer it can sustain its burst performance. So just to show you where you can see that, so when you're launching your EBS volume, so if we move into the EC2 console, we can see this behavior when we're launching our GP2 volumes. So if we change the volume type to GP2, we're going to see that here. So this 100 gig GP2 volume, this comes with a minimum baseline IOPS of 300. And because it's under 1 terabyte in size, you can see that it's getting the maximum of 3000 IOPS. It'll only be able to burst to this 3000 IOPS when it has those burst credits. This bursting ability, it only applies to volumes that are smaller than 1 terabyte. So if you were to provision a GP2 volume 1 terabyte in size or bigger, the bursting model will no longer apply. And the reason for this is because its baseline performance, so it's 3000 IOPS, meets that maximum bursting capability. So we can see here that its baseline basically is meeting the bursting demand, so that burst model will no longer apply. Then just to note that this burst model also applies to your HDD volume, so your ST1, so your throughput optimized HDD volume. This will have a baseline throughput of 40 megabytes per terabyte, and with burst credits available, it can burst up to a maximum of 250 megabytes per second. And for your cold HDD volumes, your SC1, this has a baseline throughput of 12 megabytes per terabyte, and it has burst credits that can burst up to a maximum of 80 megabytes per terabyte. Okay, so let's have a look at the actual different EBS volume types and their characteristics. So having an understanding of the different volume types and their characteristics is important when you're designing your storage solutions for your applications and workloads that you're running on EBS. So EBS includes two major categories of storage. First, we've got our solid state drive, that's your SSD volumes, and then it has its hard disk drive, your HDD volumes. So SSDs, these use a flash memory to store data, and with SSD, there's no moving parts, so data is stored on interconnected flash memory chips. And the SSD-backed volumes, these are designed for IOPS-intensive workloads such as your databases, your boot volumes, basically any workloads that require high IOPS. And the SSD volumes, these include your provisioned IOPS SSD volumes, so your IO1 and IO2, and it also includes your general purpose, your GP2 and GP3 volumes. Then we have our HDD volumes. And HDD volumes, they store data on spinning magnetic disks known as platters. So with the HDD volumes, your data is read and written by what's called a read-write head that moves over the disk surface. So HDD-backed volumes, these are designed for your throughput-intensive and big data workloads. So anything that requires a large I/O size and that's sequential in nature. And with your HDD volumes, we've got our throughput optimized, which is our ST1 volumes, and we've got our cold HDD volumes, which is our SC1 volumes. Now let's dive a bit further into these volume types and have a look at the different characteristics that each volume offers. First of all, we'll look at the SSD-backed volumes. And again, these include your IO1 and IO2, so that's your provisioned IOPS SSD volumes. And then we've got our GP2 and GP3 general purpose SSD volumes. So SSD volumes, these are optimized for small I/O sizes. So let's have a look at the general purpose SSD volumes, so your GP2 versus your GP3. So first of all, the durability. So this durability with EBS, this refers to the likelihood that data stored on the EBS volume will remain intact and accessible over time. So for EBS volumes, durability is expressed as a percentage, and this indicates the probability that data will not be lost over a given year. So your AFR, this is your annual failure rate, and this measures the expected rate of failure for a storage volume over 1 year. So again, EBS volumes, these are designed for AFR between 0.1 to 0.2%, where failure refers to a complete or partial loss of the volume. So this makes EBS volumes actually 20 times more dependable than your common disk drives, which have a 4% annual failure rate. So if you were to run 1000 EBS volumes for a year, you should actually expect between 1 to 2 failures, which is very minimal. So having a look at the size of our SSD volumes, so both GP2 and GP3 will range in sizes from 1 gigabyte all the way up to 16 terabytes. And then if we look at the performance of our GP2 and GP3 volumes, now our GP2 volumes performance, this is tied to its size. So the IOPS performance, this scales, as we mentioned, at 3 IOPS per gigabyte of the volume size. So again, if you had a 300 gigabyte GP2, this would have a baseline of 900 IOPS. So for any GP2 volume smaller than 1 terabyte, they're going to use the burst model. And this provides them with burst credits that allow them to burst above their baseline IOPS. So if you have a 3000 gigabyte GP2, it's going to have a baseline of 900 IOPS. And as this volume is under 1 terabyte, it comes with that burst balance. And that volume can then burst to the maximum of 3000 IOPS for 30 minutes when it has that full burst credit balance. So when all the credits are gone, the volume is then going to be limited back to its baseline IOPS of 900. So for the GP2 volumes that are larger than 1 terabyte, the burst balance no longer applies. So if you had a 3 terabyte GP2 volume, it's going to have a performance of 9000 IOPS. So the GP2 provides a maximum of 16,000 IOPS in total. And the throughput limit of your GP2 volume, this is between 128 to 250 megabytes, and that throughput is going to depend again on the volume size. Again, with GP2 volumes, its performance is completely tied to its size. Whereas with GP3 volumes, which are the latest SSD-based volumes, GP3 volumes come with 3000 IOPS and 125 megabytes of throughput as standard, and GP3 can support up to 16,000 IOPS and a maximum of 1000 megabytes throughput, and this can be provisioned. So the additional IOPS and throughput can be provisioned separately from the volume size at an additional cost. So just to keep in mind, GP3 will actually perform higher throughput, and it actually costs 20% less. So GP3 is 20% lower price per gigabit than your existing GP2 volumes. So in our provisioned IOPS SSD volumes, we have our IO1 and IO2, and they provide high performance for your mission critical or low latency or high throughput workloads. And the IO1 and IO2, these are designed to meet the needs of IO intensive workloads, again, such as databases that are sensitive to storage performance and consistency. And AWS recommends your provisioned IOPS volumes for your most demanding workloads. So with IO1 and IO2, the volumes are very similar in most aspects. However, there are some differences which we're going to look at now. So first of all, for durability, IO2 offers the highest durability rate. So it provides 5 nines durability. So that's 99.999%. So this means if you have 100,000 IO2 volumes running for 1 year, you should expect only one of those IO2 volumes to experience a failure. And regarding the size of your provisioned IOPS volumes, the IO1 can range in size from 4 gigabytes up to 16 terabytes. With your IO2, you can size that volume anywhere from 4 gigabytes all the way up to 64 terabytes. IO2 volumes, these can range in size anywhere from 4 gigabytes all the way up to 64 terabytes. So for IO2 volumes that are larger than 16 terabytes, these can only be attached to Nitro-based EC2 instances. So these are the newer generation type of EC2 instances. Regarding the performance of your IO2 and IO1 volumes, they have a minimum IOPS of 100. With the IO1, it has a maximum of 64,000 IOPS, whereas IO2 has 4 times that, and it has a maximum of 256,000 IOPS. So some things to note about the IOPS performance of your IO1 and IO2 volumes. For the IO1 volumes, you can only achieve that maximum 64,000 IOPS when it's attached to a Nitro EC2. So if your IO volume was attached to an older Xen-based EC2, it's only going to achieve a maximum of 32,000 IOPS. And this is the same for your IO2 volumes. So IO2 can only achieve 64,000 or higher IOPS when it's attached to a Nitro-based instance. So if either the IO1 or IO2 volumes are attached to a Xen-based EC2, you're only going to achieve a maximum of 32,000 IOPS. So if you need your provisioned IOPS volumes to achieve more than 32,000 IOPS, make sure that you're attaching it to a Nitro-based instance. And then regarding the throughput performance of your volume, IO1 has a maximum throughput of 1000 megabytes. So if the IO1 volume is attached to a Xen-based EC2, it's only going to achieve a maximum throughput of 500 megabytes. So that's half the actual maximum throughput that an IO1 can achieve. So with an IO1 volume, in order to achieve the maximum 1000 megabits of throughput, make sure you're attaching it to a Nitro EC2 instance. And then your IO2 volumes, these provide a maximum throughput of 4000 megabytes per second. And again, in order to achieve that maximum throughput, you're going to need to attach it to a Nitro-based EC2. And then having a look at our HDD-backed volumes. So with your HDD volumes, you've got your throughput optimized. This is your ST1, and your cold HDD, and this is your SC1 volumes. So HDD volumes, these are designed to handle large sequential data transfers. And this is making them ideal for workloads where data is read and written in a sequential manner, such as your streaming workloads or big data workloads. So first of all, we've got our ST1 or throughput optimized volumes, and these are designed to support frequently accessed data. So the ST1 volume, this is a good fit for large sequential workloads, such as your data warehouses, log processing, and any ETL workloads. So ST1s, you can provision an ST1 from between 125 gigabytes all the way up to 16 terabytes. And the maximum throughput that an ST1 volume will provide is 500 megabytes per second. With your cold HDD volumes, your SC1, they're designed for less frequently accessed workloads. So this would be your log archiving. And again, you're going to be able to size that from volume anywhere from 125 gigs all the way up to 16 terabytes. So the maximum throughput that your ST1 volume is going to provide is 250 megabytes. So with HDD volumes, in order to get that full throughput performance, just make sure that your application or operating system is setting an IO size of 1024 kilobytes or 1 megabyte. Remember that we said the throughput is directly related to the IO size. So in order to achieve that full throughput performance, make sure that your application is setting the correct IO size that's required for your workload. So now that we've looked at the different available EBS volume types, how do you actually decide which volume type to use for your workload? And in order to help you with that, I've created this simple workflow chart that you can use. So first of all, you need to determine, is your workload, is it more IOPS intensive or is it more throughput intensive? So if it's IOPS intensive, use SSD volumes. If it's throughput intensive, use HDD volumes. So if we're using an IOPS intensive workload, we're going to use our SSD volumes. So then you need to ask yourself, do you need more than 16,000 IOPS? If you don't, use your GP3 volume. If you do need more than 16,000 IOPS, move on to the next question. So here we'll be asking ourselves, do you need more than 64,000 IOPS? If yes, use IO2. Remember, IO2 volumes can provide you with a maximum of 256,000 IOPS. If you need less than 64,000 IOPS, use IO1. If your workload is throughput intensive, then you're going to use your HDD-based volumes. And here we're looking at your throughput performance. So here you need to ask yourself, do you need more than 250 megabytes of throughput? If you do, use ST1. If you don't, use SC1.